Um, we talked about integrating, and we talked about integration by parts, and then we also talked about trigonometric integrals. And I gave you on that's the first page on your chapter 9 formulas page. Well, so now what we're going to do is we're going to talk about the second page, which is trigonometric substitution. Now, on your test tonight, it says evaluate each integral by trigonometric substitution. That's not this. Okay? That is 9.2. That is the bottom half of this. Okay? So when it says integrate by parts, on the test it tells you to integrate by parts. That is Roman numeral number 1. And then the trig substitution for tonight's test is Roman numeral number 2. Okay? And then on your next test, we'll go into what we're doing tonight, which is Roman numeral number 3. Does that make sense? Okay. So keep that close, and let's see what we're doing. On the trigonometric substitution, this is what you have. If your problem has a radical in it, these are the substitutions that you're going to use. Now I know, I guess it was back in chapter 8, you had stuff like 1 over the square root of a squared plus u squared and stuff like that. That's not what I'm talking about. It's not 1 over anything, it's just this. You have the square root of a squared minus x squared. You have the square root of a squared plus x squared. And then you have the square root of a squared minus a squared. Same concept. You know, x squared could be something like, I don't know, 16x squared. And so you know x would be 4x. And then a could be 25, or a squared could be 25, so a would be 5. Okay? So, if you have these integrands in your problem, the integrands are the ones on the left. If you have these integrands in your problem, or if you can make your problem look like one of these integrands, then what you're going to do is you're going to substitute x for what's on the right. So if you have, for example, the square root of a squared minus x squared in your problem, or you can make it look like that, what you're going to do is you're going to substitute in for all of your x's in the problem, a sine theta. Okay, and a comes from the square root of a in your actual problem. Now, how do you use this? Well, the top is what's on the board, so that's no big deal. The bottom, and you may want to make notes on this, I don't know, but just so you understand what's going on. Case 1 goes with x equals a sine theta. That goes with the very first one on the board, okay? All right, so case 1 goes with the very first substitution, x equals a sine theta. Case 2 goes with x equals a tangent theta. And case 3 goes with a secant theta, x equals a secant theta. So, if you substitute the first one in to your problem, that's going to be case 1. If you substitute the second one in, that's going to be case 2. And if you substitute the third one in, that's going to be case 3. Okay? So that's how you're going to use this on the bottom. Now, the reason we do that is because when you start making substitutions, we go from x's to thetas. Well, in your answer, you don't want it in terms of theta. You want it in terms of x. So what you're going to do is you're going to do your integration in terms of theta, and I'll show you why. It's a lot easier. But then at the very end, you need to change all your thetas into x's. So for example, if you integrate for like case 1, if you integrate and in your integration you have a sine theta, you need to change that sine theta to x over a. Okay? If in your integration for case 1, if you have a secant theta, you need to change it to a over the square root of a squared minus x Okay? So your answer needs to be back in terms of x's. Your answers are going to look really close to your problems. Just remember, you need your answers in terms of x's. All right, so let's try one. Let's look at this one right here. So you have the integral of 1 over x squared times the square root of 16 minus x squared. Well, what I want you to do, I told you to get your chapter 8 on page out. And what I want you to do is, this would be something like u squared square root 16 minus u squared, right? If we were doing what we're going to do tonight on the test, if we were doing chapter 8, it would be 1 over u squared times the square root of a squared minus u squared. Do you see that anywhere on your chapter 8 corner page? 1 over u squared times the square root of 16 minus u squared. If you don't see that anywhere on chapter 8 formulas page, then that should clue you into the fact that we're doing trig substitution. Okay? That should let you know that we're going to do one of these 3 cases. Well, if we're going to do one of these 3 cases, what you have here is a squared is going to be 16, so a is going to be 4. And what x squared, of course, so what basically what you have is a squared minus x squared. So do you see that on your paper? A squared minus x squared. Which case would that be? Case 1, case 2, or case 3? That's going to be case 1. So, since we know that we're dealing with case 1, we know that x is going to be equal to a, which you can go ahead and plug in 4, sine theta. Now, this is what we're going to do. We are going to substitute everything in. Okay? So, for example, I'm going to have the integral of 1 over. I need to know what x squared is. I know that x is 4 sine theta. So what would x squared be? (16 sine squared theta). Okay. We can go ahead and write that substitution in. X squared is going to be 16 sine squared theta times the square root of 16 minus, I need another x squared. We already know what x squared is, so let's go ahead and put it in. 16 sine squared theta times dx. What is dx? If x is equal to 4 sine theta, what is dx? Four cosine theta d theta, right? So, substituting in for dx, we're going to put 4 cosine theta d theta. Okay, so substitution is done. We've done all of our substitution. We've done all of our calculus that we need to do. Now what we're going to do is we're going to clean this up a whole lot. And as we clean this up, we're going to be using algebra and trig. So keep up on this, okay? So what we're going to have is the integral. And I'm going to go ahead and bring the 4 cosine theta over 16 sine squared theta. Now, look underneath that radical. And again, this is a lot of algebra, and let's see if we can think about this, okay? If I have 16 minus 16 sine squared theta, do you see something that I can factor out? I can factor out a 16. And I'm going to have left 1 minus sine squared theta. But remember, all of this is underneath the radical. Square root of 16 is what? 4. So you have 4 times the square root of 1 minus sine squared theta. Alright, So, you're going to have 4 times the square root of 1 minus sine squared theta. And of course, we still have the d theta. Okay? You have this algebra written down, yes? Because I'm fixing to erase it. Are you with me? Alright, so I'm going to erase that. Now, I need to make a identity substitution. What is 1 minus sine squared theta? Okay, so if I have 1 minus sine squared theta, that's the same as the square root of cosine squared theta. But what is the square root of cosine squared theta? Cosine theta. So now I have 4 cosine theta over 16 sine squared theta times 4 cosine theta d theta. So now do you see what I did? I changed the square root of 1 minus sine squared theta. That's an identity. It's your Pythagorean identity from 113. That's the same as cosine squared theta. Well, when you square root a square, they cancel each other out and you just get the cosine theta. So, I'm going to erase that. Is that okay? Got to conserve some room here. Okay, so now you obviously see things that cancel out, yes? That's going to cancel out, and that's going to cancel out. So you're going to have 4 cosine theta is going to cancel out. Now, when the 4 cosine theta cancels out on top, it goes to 1. Don't forget that. Now, what I'm going to do you see a 1/16 in this? I'm going to pull it out front, okay? So we're going to have 1/16 times the integral of 1 over sine squared theta d theta. Okay, do you know, go back to your Cal 1 sheet. Do you know how to integrate a sine squared theta? Anywhere on your Cal 1 sheet does it show you how to integrate a sine squared theta? Anywhere on your Cal 1 sheet? No. So we've got to do something. What is 1 over sine squared theta? Using trig. Anywhere on your Cal 1 sheet does it show you where to integrate or how to integrate a cosecant squared theta? Yes. The integral of cosecant squared theta, it's number 4 on your Cal 1 sheet. The integral of that is going to be 1 over 16 times the integral of cosecant squared theta is negative cotangent. And u is theta plus c. Alright, I'm going to come up here. So now basically what we have is negative 1 over 16 cotangent theta plus c. Now, when we started all this, what did I tell you? You cannot have your answer in terms of theta. Can't have your answer in terms of theta. That's why you have these 3 charts. Okay? So which case are we working off of? We're working off of case 1. So what I need you to do is I need you to go to case 1 chart and I need you to find cotangent theta. Do you see it? Do you see the cotangent theta for case 1? And what you're going to do is you're going to replace cotangent theta with the square root of a squared minus x squared over x. Now, listen to me or you're going to get confused. When I say that I want it in terms of x, I don't want it in terms of theta, I want it in terms of x. It needs to look like the problem. Your initial problem. Did your initial problem have any trig in it whatsoever? Did your initial problem have any trig in it whatsoever? No. Watch this. Okay? Cotangent theta, I'm going to substitute in the square root of a squared. What is a squared? 16 minus x squared. For this x squared, Am I going to use 16 sine squared theta? Or am I going to use x squared? X squared. You don't want a theta and you don't want a trig. Okay, you don't want a theta in here. So that tells me, because when you're sitting there working and you're saying, okay, well earlier we substituted in for x squared, we substituted in the 16 sine squared theta. Yes, but that was so that we could reduce and integrate. Now I'm trying to get it back in terms of x. So I don't want a theta. So I don't want to put 16 sine squared theta in there. Instead, I want to leave it as x squared. All right, over. So cotangent square root of a squared minus x squared over x plus c. And technically, that's all you have to do. That answer is fine with me. If you want to go ahead and clean it up a little bit more, you can, but it's totally not necessary. Okay. So either one of those is fine with me. Now, I'm working on my test. I moved your test, by the way. Your next test, after the 9, of course, is I moved it back to the 15th. So instead of it being on the 10th, it's going to be on the 15th. Reason being is because we're not meeting Wednesday, and so there's no sense in having 2 class periods and then having another test. So I moved this test, the next test, your quiz number 4, back to the 15th, July 15th. So on your test on July 15th, you're going through here and you see an integral that looks like this. How do I know what to use? Well, chapter 8 is the only thing that resembles anything remotely like this. There's not going to be any chapter 8 on this test. There's not going to be any chapter 8 whatsoever on that test. So that should clue you into the fact that you have to use trig substitution. However, on the final exam, there's going to be bukus of integrals on that final exam. So how do you know? Am I using chapter 8 formulas or am I using chapter 9 formulas? Well, if you can't find it on the chapter 8 sheet, you ought to know you're using chapter 9 formula. Okay? All right, let's try another one. Let's go here. If we have the integral of 1 over the square root of 4 plus x squared. Now that's going to be a squared plus x squared. Square root of a squared plus x squared. What case is that? That's case 2. So a squared is equal to 4. So a is going to be equal to 2. And x, what's my trig substitution going to be? 2 tangent theta. Do you see why? My integrand is comparable to a squared plus x squared. The integrand is comparable to a squared plus x squared. And the only integrand that has the square root of a squared plus x squared is the one in the middle, which is case 2. So x is going to be equal to a, which I've already told you is 2, tangent theta. Now, we're going to have to make some substitutions. Because you don't have one that looks like that. I know which one you're looking. You're thinking about. You're thinking about 1 over a tangent inverse. That doesn't have the square root. That's the only one on there that looks remotely similar. The other one it has a 1. You have u squared plus 1, and we have u squared plus 4. And then the other one has that's interesting. very interesting. The chapter 9 techniques, and I will check into that because right now I'm not seeing it. But anyway, we'll work on it. All right. So if we use trig substitution, you're going to have x is equal to 2 tangent theta. And so dx is going to be 2, and then the derivative of tangent is going to be what? Secant squared theta, d theta. And then x squared, because we need that, is equal to 4 tangent squared theta. All right, let's substitute in. So we're going to have the integral of 1 over the square root of 4 plus x squared is going to be 4 tangent squared theta. And then dx is going to be 2 secant squared theta d theta. All right, so what are we going to factor out? So we're going to have 2 secant squared theta d theta. We're going to factor out a 4. The square root of 4 is going to be 2 times the square root of 1 plus tangent square theta. What identity is that? What identity is that? So we're going to have 2 secant square theta over 2 times the square root of secant square theta d theta. Reduce, and you can cancel those 2's out anytime you want to. So the 2's are going to go away, and then the secant square theta, one of the secant square secant thetas will cancel out. So we have the integral of secant theta d theta. Now, if you have the integral of secant theta d theta, look back on your Cal 1 sheet. Do you have an integral for secant theta? What number is it? Number 12, right? So the integral of secant theta, again, I'm going to come up here. The integral of secant theta is going to be the natural log of secant, u in our case is theta, plus tangent theta, and of course you have the plus c. Why is that? You got what from? Your Cal 1 sheet, not Cal 2. We will in a minute. The integral of secant theta is number 12 off of your Cal 1 sheet. Do you have your Cal 1 sheet? Yeah. Okay. Look at number 12 on your Cal 1 sheet. All right. So again, we don't want it in terms of theta, so we have the natural log of secant theta. What case was this? Yeah. This was case number 2. All right, so case number 2, we need a secant theta. Secant theta is going to be the square root of a squared, which was 4, plus x squared over a, which is 2, plus tangent theta, which is going to be x over a, which was 2, plus c. And again, you can leave it like that, or if you prefer to put them together, that's fine. Whatever, doesn't matter to me. And Sabrina, I will, right now I'm not seeing it, but I know there's a reason and I will figure it out. Because if you could have used either one of them, the answers would have came out the same. And they're not. So I will get back to you on that one.
If you go back to the second to last on the left there.
Mm-hmm.
I got all the way to the secant square, square root of secant square. Either the square root and the secant square cancel out.
Yeah, anytime you take the square root of anything squared,
Okay.
you just get what you're squaring. The square root and the square cancel out always.
Okay, so on the bottom, there's going to be secant, right?
Mm-hmm. And that secant,
Cancels out.
this
Okay.
secant cancels out one of those.
Okay. Okay.
And so it just leaves you with a secant. Anything else? That really bothers me. But I cannot see that. That's okay. We'll deal with it. Okay, so let's look at this one. For this one, I know in chapter 8 you don't have anything that has a square root on the top. So using your chapter 9, what we have here is x squared minus a squared. Do you see anything on there that has a square root of x squared minus a squared? Case number what? Case number 3. Case number 3 tells me, well, I'll just go ahead. A squared is equal to 9, so a is equal to 3. You're going to need that. And x for case number 3 is equal to a, which is 3 secant theta. We're also going to need an x squared, which is 9 secant square theta. And you're also going to need a dx, which is going to be, what's the derivative of secant theta? Secant theta, tangent theta, d theta. Where'd that come from? How did I find the derivative of secant theta? Where did that come from? Your Cal 1 sheet, your Cal 1 formula page. Alright, so let's substitute in. So we're going to have the integral of the square root. X squared is going to be 9 secant square theta minus 9 over x, which is 3 secant theta, times dx, which is 3 secant theta tangent theta d theta. And again, if you want to go ahead and cancel out the 3 secant thetas now, you can. If you want to wait till later, you can do that too. It's all going to work out in the wash anyway, so it doesn't really matter. Alright, so, do you see what we're going to do on the top? You tell me, what are we going to do on the top? Nobody knows? That's bad. Yeah, we're going to factor out a 9 and actually take the square root of it, so it's going to turn into what? 3 square root. Can you go all the way? Secant squared theta minus 1 is actually going to turn into what? Yep, tangent squared theta. But we'll save that for down the road. So we have 3 secant theta over 3 secant theta times, again, if you want to cancel those out, you can. Alright, so again, I'll go ahead and write it. That's going to be tangent square theta. That's an identity. And then when you take the square root of that, that's going to turn into 3 tangent theta over 3 secant theta times your dx, which is 3 secant theta tangent theta d theta. Okay. Now, clean things up. The 3 secant thetas will cancel out. And what you have is the integral of 3, which you can pull the 3 out. Tangent squared theta d theta. Alright, so that's the cleanup. So now we are left with 3 tangent squared theta. Do you know how to integrate a tangent squared theta? Look on your Cal 1 page and tell me, do you see an integral for tangent squared theta? No. For your Cal 1 sheet, you do not have a integral or antiderivative for tangent squared theta. So you go back to your trig. Okay, if you can't fix it using the Cal 1, then you go back to your trig. So this is actually going to turn into 3 times the integral, and just go back to what we did earlier, 3 secant theta minus 1 d theta. Okay, do you know how to integrate a secant square theta? You should. So this is going to be 3. Do I need to break these apart, or are you going to see what I'm doing? I'm going to integrate secant square theta, and then I'm also going to integrate the 1d theta. If you integrate 1d theta, what is that going to turn into? Theta. Okay? The integral of 1d theta is theta. So, the integral of secant square theta, that comes off your Cal 1 sheet. That's going to be tangent theta minus, again, the integral of 1d theta is simply theta plus c. Alright, so there's your integration. Now, let's substitute back in. I'm going to go ahead and take the 3 through. So you're going to have 3 tangent theta minus 3 theta plus c. Okay, I just distributed the 3 through. Because if I don't, I'll forget it. Okay, go to your Cal 2, Chapter 9, Formulas page. Which case are we working off of? Case 3. So we're going to have 3 times tangent theta. Case 3 tangent theta is the square root of x squared minus a squared over a, which is going to be 3, minus 3 times theta. Do you see theta on your sheet? What is theta equal to? Secant inverse of x over a, x over 3, x over a. Do you see something that will cancel out? These 3's will cancel out, right? What about the 3's on the right? Can I cancel the 3 with the x over 3? Why? X over 3 is an argument. It's not a constant, so I cannot cancel those out. Alright, so we're going to have the square root of x squared minus 9 minus 3 secant inverse of x over 3. And of course you have the plus 2. And that's all you can do with that. That's the only thing that you can do with that.
Something else to have in the truth.
Well, on this one you have to because of theta. The main thing is you don't want any thetas. But in our case here, theta, just simple theta, is equal to the trig function. Because of, I don't know where my laser pointer is, because of where you have x is equal to 3 secant theta, in order to figure out what theta is equal to, it's going to have a secant here. Main thing though is you don't want your thetas. It needs to be in terms of x's, no thetas. Something else. Okay, let's do one more. Have you seen anything like this? X cubed times the square root of x squared minus 25. This is going to be x squared minus a squared. Square root of x squared minus a squared. But, or the square root of u squared minus a squared, whatever. We have that x to the third up front. Okay? And there's no way that we can compensate for that unless we multiply everything by x, which we don't want to do that. So, let's use x squared minus a squared is going to be what? Which case again? It's going to be case number 3 again. Okay? And that's because you have the x squared minus a squared. So, again, a squared is equal to 25. So a is equal to 5. Now, x is equal to a, which we know is 5, secant theta. Now, what all are we going to need in order to substitute in? We need an x squared. Yes, x squared is going to be what? And we also need an x cubed. What is x cubed? 125 secant cubed theta. Well, let's go ahead and get dx. Okay, we know x is 5 secant theta, so what is dx? I'm not going to have enough room. What is dx? What's the derivative of secant theta? Where can you find that? It's on your Cal 1 sheet, is it not? The derivative of secant theta is on your Cal 1 sheet, and that's going to be secant theta tangent theta. Okay, now let's sub in. So we're going to have the integral of 1 over x cubed, we said was 125 secant cube theta times square root of x squared, which is 25 secant squared theta, minus 25, and you can already see what we're going to do, times dx, which was 5 secant theta tangent theta, d theta. Okay, so that's just all your substitutions. Now, let's clean it up a bunch. I'm going to move the 5 secant theta tangent theta over on top. The 125, if you want to go ahead and cancel some out, you can. I'm not going to right now. All right, underneath the radical, I'm going to factor out a 25 and then take the square root. So the 5 is going to come out. And then what's left underneath is going to be secant squared theta minus 1, which is going to go to what? Tangent. So we're going to have the integral of 5 secant theta tangent theta over 125 secant cube theta times 5. Can you go all the way? The identity for secant squared theta minus 1 is tangent squared theta, but the square root of that is going to be what? It's just going to be tangent theta, right? The identity for secant squared theta minus 1 is just going to be tangent squared theta, but the square root of that is just going to be tangent theta. So we have 5 tangent theta. All right, now let's cancel things out. We know the 5 will go with the 5, and we know the tangent theta will go with the tangent theta. What else? One of the secant thetas, right? So that's going to go to 2. Okay, so on top, what am I left with? Just a 1. So what am I going to bring out front of the integral? 1 over 125. Very good. Times the integral of still 1 over secant square theta d theta. Now, do you know how to integrate 1 over secant square theta? Do you have an integral for 1 over secant square theta? No. You have an integral for secant square theta, right? But that's not what we have. We have 1 over secant square theta. Okay, so let's keep going back. What if we tried u substitution? What if we let u be secant theta? Then du, something that we have to check off, would be secant theta tangent theta. That's not going to work either. So let's keep going even farther back. Let's go back to trig. Well, if you have 1 over 125 times the integral, 1 over secant square theta is going to be what? Cosine square theta? D theta? Do you know how to integrate cosine square theta? Do you know how to integrate cosine square theta? Are you going to do it tonight on your test? I hope you're going to do it tonight on your test. The integral of cosine square theta. Go back to Roman numeral number 2. Roman numeral number 2. Cosine squared x, cosine square theta. So we have 1 over 25, or 1 over 125 times the integral. We can substitute in for cosine square theta. There's probably even a trig. Because if you use what? If you use 1 minus sine square theta for cosine square theta, then you would have to still use your half angle identities for the sine square theta. So you're going to have to use a half angle identity regardless. Let's just go ahead and use it here. Cosine square theta. How you want to write this is your choice. I'll just go ahead and do the substitution that's on your paper. That's the one that's on your paper. That's not the one that I use, but that's the one that's on your paper. Or it's the one I use, but that's not how I write it. Okay. So what I'm going to do is I'm going to take a 1/2 out front. Okay, this is the way I prefer to write this. And I think I told you that last time when we actually did these. That's the way I prefer to write it. That way it gets rid of the fraction because I can take the 1/2 out front. Okay? So if I take the 1/2 out front and multiply it times the 1 over 125, that's going to give me what? 1 over 250 times the integral of 1 plus cosine 2. It's not an x, it's a theta. Let me fix that. D theta. Alright, so we're going to have 1 over 250. Now this, I hope you can do because you're going to be tested on it tonight. You're going to have to do this tonight. What's the integral of 1 d theta? Theta. What's the integral of cosine 2 theta? One half sine 2 theta. Good. Very good. Why? Well, the integral of cosine 2 theta, d theta. U is not just theta. It's 2 theta. So you have to use compensation. So if u is 2 theta, then du is 2 d theta. I don't have a 2 d theta. I just have a d theta. So you're going to have to use the 1/2 du. to get the d theta. Okay? So you have to, anytime your argument is not just the variable, you have to use compensation. All right, let's get this thing back in terms of x. Try to anyway. Oh, I guess I need to do that. All right, so we have 1 over 250. What is, let's go ahead and distribute that, because if I don't, I'll forget it. So that's going to be 1 over 500 sine 2 theta. That makes me feel better. Okay, so you have 1 over 250. What is theta on your sheet? Theta is, which case are we on, 3? Theta is secant inverse of x over a, which is 5, plus 1 over 500 times sine 2 theta. What are we going to do there? I don't have anything on my page that says sine 2 theta. So that's a problem. Can you tell me what we're going to do? No, I've already integrated. You can't do U substitution because you've already integrated. Good thought, though. No, can't double it because it's straight substitution. What are you gonna do? I don't have a sine 2 theta on my paper. Anything in Cal 1 tell you how to do something with sine 2 theta? You're at trig at this point, okay? You are at trig at this point. So what is sine 2 theta? What's the same thing as sine 2 theta?
2 sine.
Very good. 2 sine theta cosine theta. Now, do you have something on your paper that will allow you to do that? Sure. I'm going to go ahead and reduce this 2 with this 500 is going to take that back down to 250, right? All right, so the first one, you're done with it. Just keep writing it down. What is sine theta? Case number 3, sine theta is the square root of x squared minus a squared, which is 25, over x, times cosine theta is a, which is 5, over x. Now I can reduce again. That 5 will go with that 250 and make it just a 50. One more time. So we're going to have 1 over 250 secant inverse x over 5 plus, how you want to write this is completely and totally your choice. I'll go ahead and multiply it all together just so it'll look nice and neat. So you'll have x squared minus 25 over 50x squared. And of course you have a plus c. Okay, so let's go more. All right, so that is 9.3. Not going to do 9.4. It deals with partial fractions. How many of you, just out of curiosity, how many of you in 112, how many of you had an instructor or a high school teacher that taught you how to do partial fractions? I know Mr. Arnold taught you. Okay.